Today's lesson is called Functions. So we're going to start with a little opening activity. It says, let's see what you remember. Which of the graphs represent functions? How do you decide? So at this time, I'd like you to pause the video, answer the question, and when you're ready to go over the answers, you can resume the video. Okay, at this time, you've had an opportunity to see what you remember. I wanted to know if you knew which of the graphs represents functions and how do you decide? So the correct answer should have been number 1, number 2, number 6, and number 7. And then you learned about this in the previous year's math curriculum. So hoping you would remember one of the two options you have to decide whether these graphs are functions or not. The first option would be to say that each input has one output, which is the definition of a function, or that it passes the vertical line test, which is a special test you learned about last year that you can use for graphs only to determine if it's a function or not. Today's lesson is going to go back to functions and review the things that you've learned from the previous grades, as well as add on to that idea of what a function is. So we'll move on now to our notes, the main ideas, definitions, and some examples. So starting with a function. A function is a special relationship between values. Specifically, though, we want to define it as each input, which are x values, has exactly one output, which are y values. Now, going along with that, you learned about the vertical line test. When given the graph of a relation, the vertical line test can be used to determine whether the relation is a function. The vertical line test states if a vertical line intersects a graph more than once, it is not a function. So if I actually go back up to your opening activity, you can see why number 1, if I drew a vertical line, it only intersects once. Number 2, only intersects once. Number 6, only intersects once. And number 7 only intersects once. When I go to try to do that for number 3, the vertical line lands right on top of the graph in number 3, so it intersects everywhere. They're the same exact. Here you can see it intersects twice. Here's an example of it intersecting twice, which is why those ones are not functions. So now let's go through some examples and indicate if the following relations are functions and explain why or why not. So we'll start with ordered pairs. You can see here we have a list of ordered pairs or coordinates, 0, -3, 1, 4, 3, 4, and -4, 5. So you want to make sure that each input only has one output. So 0 only gets paired with -3, an x value of 1 is only paired with 4, an x value of 3 is paired with 4, an x value of -4 is paired with 5. So each input only is paired with one unique output. So this is a function. And we would say each input has one output. Now a special note here, we look for no repeated x values. As long as I have no repeated x values, that's going to be a function. I do not want you to confuse that with repeated y values. There are 2 y values that are 4, but that's okay. We're only concerned with each input having one output. 1 is only paired with 4. 3 is only paired with 4, so that's okay. When we go to the other example, 5, 4, 4, 3, 4, 2, 3, -4, I see repeated x values. Which means if I were to draw a quick little picture over here, 4 is being paired with 3 as well as being paired with 2. So an input of 4 has more than one output. So this is not a function. And I'm going to write exactly what I just said. Input of 4 has 2 outputs. And again, a quick little trick for you to look at is there's repeated x values. Okay, so that's how you would determine for ordered pairs. Now let's move on to a graph. We've already kind of talked about this within the opening activity and the vertical line test, but we're going to take a look at some more examples. So for a graph, you are still allowed to use each input has one output. You can use that reasoning for any representation of a function. The only time you can use the vertical line test is when using a graph. So if I was going to start drawing vertical lines anywhere on this picture, you would see that it only intersects my graph one time. So this is a function because it passes the vertical line test. Now again, you could also say because each input has one output. If I look at the next picture and I start to draw vertical lines, so far so good. They're only intersecting in one spot. But then when I draw this line, it intersects in 2 spots. So this is not a function because it fails the vertical line test. You could also explain it by saying an x value of -3 has more than one output or has 2 outputs. So you have options when it comes to the graph, but most people will choose to use the vertical line test. Moving on to a table is going to work very similarly to how our list of ordered pairs worked. You want to make sure that each input, or x, is only partnered with one output, or y. So again, you can look for those repeated values. I don't see any repeated x values, which means -2 is only paired with 5, -1 is only paired with 3, 0 is only paired with 0, 1 is only paired with 3, and 2 is only paired with 5. So again, does it matter that the -1 goes to the 3 and also the 1 goes to the 3? No, we only care about the input side. So this is a function because each input has one output. When we look at the other side, I do see repeated x values. I have a 1 here and a 1 here. And if I actually draw that out, that means 1 is going to 5, and it's also going to 8. So I can see an input of 1 has 2 outputs. So this is not a function. We had a repeated x, which means an input of 1 has 2 outputs. So that would be not a function. We also need to be able to identify a function from a description. So the assignment of the members of a football team to jersey numbers. And they're showing you what that looks like in function notation, which we learned about previously. So the members of the team are being assigned a jersey number. So in this situation, you're trying to think of the fact the input is the team member, the output is the jersey number. That means that this is a function because each player is assigned one jersey number. So I'm still using the definition of the function, but do you notice in my explanation, I explained it in terms of the situation. So you want to be specific in the directions for whether it's a function or not, based on the description you've been given. So if I look at the other one, the assignment of zip codes to residences. So for example, the zip code for Lockport is 14094. I want to know if the assignment of zip codes to residences is a function or not. Well, think about it. Let's say 14094 is Lockport. There are many families that live in Lockport that would all have the same zip code. So that means this is not a function. I'm going to say a zip code is assigned to multiple residents. So that's why that would not be a function. Again, my explanation supports the original description that I had. Now, the last one I want to talk about within this is a mapping diagram, which you've actually seen me draw in a couple places to help me figure out if something was a function or not. And that's something you can do as well. You can use the mapping diagram in other situations to help you determine function or not a function. When you're looking at a mapping diagram, you want to make sure that the x side, which again is the input, only has one arrow coming from each element inside, matching with an output in the y section. So if I look at this, -1, 0, 1, and 2 on the input side, they all only have one arrow coming from it. So that makes this a function because each input has one output. And again, it is okay that two things are going to an output of 2. That's not the concern. We just want to make sure every input only has one output partner, which we satisfy in this first mapping diagram. When I go to the second one and I look at the input side, which is the x, remember the output is your y, I notice a problem right here at -1. There are 2 arrows coming from it, which means -1 is paired with -1, but also 7. That's not okay. So here, this is not a function, and that's because an input of -1 has 2 outputs. Now let's see how we apply this idea of function to an example with a graph. So it says, graph the given function and answer the accompanying questions. F of x equals 2x plus 6. First, we're going to graph it. So since it's in mx plus b form, I know my slope is 2 over 1, which means I'm going up and to the right, and my y-intercept is 6. So I will start at 6 on the y-axis, and I will go up 2 to the right 1. If I run out of space, remember I can go down 2 to the left 1. I'm going to connect those. Make sure you use a ruler or straight edge, arrows on both ends, and I'm going to label it with f of x, its equation, equals 2x plus 6. So the first question says, when the input is 2, what is the output of the function? In other words, find f of 2. So this is a bit of a review from our previous lesson. Looking at this question, an input of 2 means an x value of 2. So I'm going to find x is 2, follow it up. We're talking about this coordinate right here, which corresponds to a y value of 10. So I know that f of 2 equals 10. I know that because f of 2 means that my input, or x, is 2. And I had to find the output. If I look in part B, it says if f of x equals -8, find x. So f of x, remember, is the same thing as y. They're telling me the y value is -8. So in this example, they've given us the output is -8, which means y is -8. So I'm going to go to the y-axis, and I'm going to find -8. I'm going to follow it over to find the coordinate and see that the corresponding x value is -7. So x equals -7. In C, the graph of f of x equals 2x plus 6 is considered a function. Explain why. Well, looking at that and knowing what we've talked about before, if I were to draw a vertical line anywhere on this picture, I'm only intersecting my graph one time. So it passes the vertical line test. Or remember, you could say each input has one output. My last question says, are all lines functions? Explain why or why not. So I want you to pause the video for a second and think about this on your own. Maybe sketch out some examples. I want to know, are all lines functions? Explain why or why not. So pause the video and resume when you're ready to discuss it. Okay, so are all lines functions? The answer here should be no, okay? Remember what it means to be a function. Each input must have one output. And an example I can come up with of a line that would not be a function is one you actually saw in the beginning of your lesson today. For example, a vertical line is not a function. So if we think about a vertical line, that means that your x values are all the same and your y values are different, which is why this would not be a function. So now I would like you to complete the closure question. It says sketch two different graphs that are not functions. So at this time, pause the video, make your sketches, and then resume the video to see two examples. Okay, so at this time you've had a chance to try the closure. Here are two examples that I came up with. Remember, if you want the graph to not be a function, it has to fail the vertical line test. You have to have inputs that have multiple outputs. So like we just talked about, I sketched a vertical line, which would not be a function. And then in my other graph here, if I draw the vertical line test, it's going to cross in more than one spot. So this is another example of something that is not a function. So check your examples, see if you think you've created non-functions. If you'd also like to add mine to your picture so you have a couple more examples of non-functions, that would be a great idea. And that concludes your lesson on functions.